Greetings from the Hermitage, and welcome to this presentation entitled Fractions 2. In Fractions 1, we covered the greatest common factor, and in this presentation, we're going to cover the least common multiple. And those two presentations combined is going to lead us into Fractions 3, which is going to be adding and subtracting fractions with different denominators. So, as far as least common multiple goes, let's first kind of show what a multiple is. So we have this slide, and I'm going to use a couple of numbers as my bases. This is going to be 16 and 24. I chose these two numbers because they allow me to give a good presentation on what multiples, least common multiples, are. So, whenever we take a base number like 16 and we multiply it by another number, we're multiplying here, the result of that is a multiple. And you know 16 times 1 is 16. And I'll just keep increasing the factor. That's going to be 32. 16 times 3 is 48. 16 times 4 is 64. 16 times 5 is 80. And then 16 times 6 is 96. All of the numbers in this column are called multiples of the base number. All we did was multiply. Multiply gives us a multiple. Now we'll talk about what a common multiple is. Yeah, I can't even spell, huh? That's probably why I teach math instead of English. So we're going to do the same thing to base 24 that we did with base 16. I'm just going to multiply it by a sequence of numbers. That's going to be 24. 24 times 2 will give me 48. 24 times 3 will give me 72. 24 times 4 gives me 96. 24 times 5 is 120, I hope. And then 24 times 6 is 144. So once again, all I did was multiply the base by the factors, and when I multiply, it gives me a multiple. But now I'm interested in a common multiple between the numbers with base 16 and the numbers with base 24. Now, a common multiple simply means that once I've multiplied a number, like 16, I'm looking for the same multiple when I multiply the number, the base 24. And if I just kind of come down, 16 is not a common multiple. 32 is not common to this. But once I get down to 48, I'll double check that. And that is a common multiple with this. 48 is a common multiple for the base 16 and base number 24. And I come on down 64. And we'll check it to show that I did it. 64 is not common to base 24. I'll go to 80. That's not a multiple of base 24. I come down to 96 and I check over here on the right hand side, and 96 is a common multiple for both base 16 and base 24. So 48 is a common multiple to both. 96 is a common multiple to both. Let me get a new page. I can now write this. Sixteen times 3 equals 24 times 2. And our multiple that was the same for both was 48. And I can also write for the second common multiple, 16 times 6 equals 24 times 4, and we know 96 equals 96. But we're looking for, in particular when we're working with fractions, we're looking for the least common multiple. And between these two, okay, this is 48 and this is 96. This column to the left, this would be the least common multiple. And the thing that I want you to pay particular attention to is that to get the least common multiple, the factors that we multiplied here and here, and then here and here, the multiples that we multiplied by were the smallest possible number. So 3 is smaller than 6. 2 is smaller than 4. So to get the least common multiple, this is the critical point here, to get the least common multiple, we have to use the smallest possible factors. Now, in general, moving my papers around here a little bit could be noisy. In general, whenever we're getting common multiples, we'd write something like this. 16 times factor 1 has to equal, in this case, 24. times factor 2. So here we go. That 3 is factor 1. And that 2 is factor 2. Let me get a new page, give myself a little extra room. So from the previous page, I had 16 times factor 1 equals 24 times factor 2. And if I recall correctly, F1 equals 3 and F2 equals 2. Now I'm going to show you a little magic about how to get these numbers here. Pay close attention. I want to get all the numbers on one side of the equal sign and the letters on the other side of the equal sign. I'm going to start here with 16 times F1. And I'm going to eliminate that F1 by multiplying this by 1 over F1. And if I multiply the left-hand side of the equal sign by some number to maintain the equality, I have to multiply this side by 1 over F1. And when I do that, we get 16 equals 24 times F2 over F1. So I have all of my letters on one side of the equal sign, but I don't have all my numbers on the other side. So to do that, I'll multiply this side by 1 over 24. And to maintain the equality in the equation, I have to multiply the other side by 1 over 24. When I do that, these 24s cancel out just like the F1s canceled out up here. And at the end of the day, I have 16 over 24 equals F2 over F1. Whenever we have an equation like this, when we have two fractions or two ratios equal to each other, then there's a one-to-one correspondence between the numerators and a one-to-one correspondence between the denominators. But wait a second. I said that F2 equals 2, and I said that F1 equals 3. But here I have F2 equals 16, and I have F1 equals 24. So it doesn't quite look right yet, but we're going to make it right by using the information that we got in the previous presentation on the greatest common factor. Let me go ahead and get a new page. So I have 16 over 24 equals F2 over F1. All I'm going to do at this point is reduce this fraction. And we'll do kind of a horizontal factor tree, and I'll do it step by gory step, so it's a little bit easier to see, a little bit easier to follow. 16 is the same thing as 2 times 8. And that is the same thing as 2 times 2 times 4. And that is the same thing as 2 times 2. And 4 is 2 times 2. So now I have 2 times 2 times 2 times 2. And now I'll factor 24. 24 equals 2 times 12. And 12 is 2 times 6. And 6 is 2 times 3. I can't factor that any further. All of these are prime numbers. So I'll write the factored form of 24 here. It's going to be 2 times 2 times 2 times 3. And that's going to be F1 over here. I look here. I have a 2 in the numerator, a 2 in the denominator, another 2 here, another 2 here, another 2, and another 2. Those are all common factors. And if I box that out, 2 times 2 times 2 is 8. So that's going to be 8 times 2 over 8 times 3 equals F2 over F1. 8 is my greatest common factor, and 8 divided by 8 is 1. Those just cancel out, and now I'm left with 2 over 3 equals F2 over F1. That's kind of an intermediate result. I'll go ahead and box that in. Let's continue on the next page. So up until now, I have this. I can rewrite this as 2 over 3 equals 16 over 24. Recognize that all I did was take this 16 over 24 and reduce it to that fraction. Now I'm going to say something that I never ever say because I hate it, but we're going to cross multiply. I'm going to multiply that number times 16 and that number times 24, and we get 3 times 16 equals 2 times 24. 48 equals 48. And because 2 and 3 are the smallest factors of 16 and 24, whenever we do this cross multiplication, we get the lowest common multiple for 16 and 24. That's a very, very easy way to do that. It works like 100% of the time. Now on the first slide, whenever we made those tables and we just kept multiplying down, multiplying to determine our common multiples and our least common multiple, You can do that for small numbers like 16 and 24. But once the numbers start getting larger and you're looking for a least common multiple, that becomes problematic and you can be writing numbers forever. So I'm going to show you an example now with larger numbers and how easy this becomes whenever you do this thing that we just did by reducing the fraction. So let's say I have the numbers 36 and 184, and I want the least common multiple. The first thing I'm going to do is rewrite those as 36 over 184. And I'm looking to reduce that fraction. And the way I do that is to write the prime factors of each of those numbers. And hopefully I've given myself enough room here to be able to do that horizontally. In your homework assignments, whenever you're factoring these, it's going to be a lot easier to write the factorization out horizontally than it is to write a factor tree vertically. But I'll show you step by step. I know that 36 is an even number because 6 is an even number. That's going to be 2 times 18. And I know that 18 is 2 times 9. And finally 9, I'll factor the 9, and 9 is 3 times 3. So at that point, 2 times 2 is 4, times 3 is 12, times 3 is 36. So that factorization looks pretty good. And now I'm going to factor 184. I know that 184 is an even number. So that will be 2 times, and 184 divided by 4, I think, is 92. And 92 is an even number. And I think the factors are 2 and 46. 46 is an even number. So that's going to be 2 times 2 times 2 times 23. 23 cannot be factored. It's a prime number. So at this point, I can go ahead and stop. So I just have 4 factors in each of those. Instead of writing a whole page, maybe 100 numbers down the page, I've simplified it into just 4 factors each. Now I'm going to factor out the greatest common multiple. Here's a 2 up and a 2 down, a 2 up and a 2 down. These 3's are not common to the denominator. There are no more 2's in the numerator. There's no 23 in the numerator. So now what I have is this equals 2 times 4. 2 times 2 is 4 times 9 over 4 times 23. And we know that that is the same thing as 36 over 184. The 4's cancel out and leaves me with this. This is an intermediate result. Now to get my lowest common multiple, I'm going to cross multiply. Looks like I've made a little mistake here. Let me go back and correct. I forgot that 2 right there, so this is going to be 9 over 46. Let me get rid of that 23. And I'll get rid of this 23. And this was going to be 46. And this would be 46. The reason I know I made a mistake is because on a separate sheet of paper I started multiplying these out, and when I multiplied 36 by 23 I didn't get the same thing as 9 over 184, so I went back and corrected myself. So I'll get a new page. Now I'll multiply making a mess here. 184 times 9, and that's 1,656, and then 36 times 46. 6 sixes are 36, 3 sixes are 18, add 3 is 21, 6 times 4 is 24, carry my 2, 12, add those, 1,656. So the least common multiple, the least common multiple of 36 and 184 equals 1,656. So that's how we do it. It makes it really, really easy to get the least common multiple if we do the prime factorizations and factor out that greatest common multiple, and then at the end of the day we just cross multiply, and that gives us our least common multiple. Now in the next presentation we'll show how to use all of this information, the greatest common factor and the least common multiple, to get the least common denominator when we add fractions. So guys, thanks for learning. Thanks for watching. And there's only one thing left to say. And it's that's all, folks. Stay safe. Con cuidado.